kbps of data to be sent, which is very rare in a small device. It only takes 3 seconds. So, whereas if you want a lot more, particularly in the last slide, we showed one of the slides, and a vibration analysis, you need a lot of data to be sent. You have to send the entire waveform, entire signature of the vibration to a cloud or you can even locally process it depending on what's the kind of IoT case the device it is. So in that case, you need to do it on CAT M1 and all. So where you get very high bandwidth. See, you get 1 Mbps, it's too much. So these are all peak rates. What is really realizable in the field is a lot lesser than this. So you can say about less than half only you get because of congestion. This is as tested the band can give you this kind of throughput, but in effect you don't get this much, like 1 Mbps. And here also 250 kilo, you don't get 250 also, you get around 120, less than that sometimes, but it's good enough for the purpose. So this again another comparison with LT1 and LTE. So I'm not going to go too much in detail. I leave this slide. You can see it later when you want to. It just describes in-band and out-band carriers and then spread spectrum, direct sequence spread spectrum. All this, the difference between that and this in terms of the spectrum, spread spectrum versus a fixed spectrum, a direct sequence, spread sequence, all a bit more detail to talk in detail. This only tells about the range that you can achieve by doing that technology. If you do this, you get a better range. Then it takes the reflections and all into consideration. Other one filters some of the reflections. So reachability of the signal to the device is more enhanced when you go for these are the options. So that is what this page can describe. These are the protocols. There are and for IoT, since it has to save battery power, it's most important because they're working on battery most of the time. Most of the devices they're all on battery. So these are the protocols. All these protocols are very lightweight protocols. For example, your HTTP, which you use every day, when you surf and it's all on HTTP, HTTP just secure HTTP. There are 154 bytes per every message. Even if you say yes, suppose in a page you want to accept, you say yes, you accept. That signal goes with 154 bytes of overhead. Just you have said yes, you agree to term, you say and just submit that only. Even with that, it goes with 154 bytes. In this, it's very light. I'll show you the protocol because you can't have those over. It's not needed for this kind of thing. So these are the 4 things. This one is more popular now, MQTT. And this is still there. This is not that it's in America more. They're also going away slowly. The people, these 2 are more. This I don't know much about, not much about, and not really in use. These 2 are in use. And in India, they know. So this MQTT was actually brought out by IBM. IBM are the pioneers who brought this protocol to the world. Initially, you see in Wikipedia, you'll get all that. Initially, it was on chargeable basis. It was a subscription and all. So many devices, you could pay them small amount of dollars to have things or that sense. But no more, they found that it's becoming so ubiquitous. Everybody using it, no point. So they gave it to the world free. For almost 6-8 years, it was proprietary to IBM. Now it's open thing. It's open protocol. There's no subscription of that. So MQTT is all about that. The message queuing, telemetry, transport. So it works on layer 4, layer 5, TCP, and it uses all the security in case you want your data to be very secure, which is not true in most of the cases. But in case of defense application, you want it, the battlefield. Of course, you won't have network, that's a problem. But anything like that, something in the defense, you want a security. All that also can be done. This SSL, secure, this one, secure socket layer, etc. Can also be used. On it works on TCP, layer 4 of let's say 7 layer. On 5th layer, all these are available, SSL. So IoT data can go on SSL. So it can be made secure also. So man in the middle cannot draw the data as it goes from the device to the tower nearby. Man in the middle cannot take that. So SSL is as secure as your website, which is HTTPS. IoT is not that way. It's fully grown. It's a very good technology which has grown to its best. It's got security feature also in this, though it is so small. Then publisher subscriber mode. Yeah. Before I go to this, I've got one or two devices. Let's pass it on. You must have already seen this. So this made by Glenn. Glenn makes it. We are fully integrated. It's a working one. So there are two this thing I've circulated. The black one, what you see with Geo's name is there. That is a working one. It's a live one. Connected. It's not working. It's got a SIM and all inside. And the other one, which is a transparent one, I ordered it on Amazon. You get it. That's a Raspberry Pi actually, which can be also an IoT. IoT can be even smaller than that. It's very powerful. In fact, it's got too many things in that. IoT can be even a lot smaller. And when they are made in good volumes, these IoT can all reach a price of now 1,000 rupees. The bad thing is around 5,550 rupees in our per kilo around. You got to embed it and do the full job. But not suppose you have a device which you want to convert it to IoT, we're talking of making another 1,000 more for that. I'm taking a simple application. In vibration, it will be a little more because the processing and all you want to do, then those chips at cost will extend. But a mere standard IoT for which almost 80% of the application, so is less than 1,000. Basically, it's come down to that level. Probably it will come down further also. There is no more SIM and all is needed. There are eSIM concepts and all. The processor are able to handle those eSIMs. So it will be easy. You don't have to even have a slot for putting a SIM, getting it to do an auto registration, and just an eSIM only. There is no SIM, physical SIM in that. Okay. So that's what that's the speed at which this IoT is going. So this MQTT protocol, what I said, is a publisher subscriber model. That is, the device doesn't know who is a subscriber until all this came in a factory or any place. The device which is producing some data is connected with certain things, fixed it is. Okay, you go to a PLC or something. The producer and the consumer of data is linked. Here, the producer is very autonomous. He simply publishes into a server called broker. That's the term they use. It's nothing but a broker in some remote place. You can call it crowd. It publishes. Doesn't know who are the subscribers. It need not. There can be more subscribers sometimes, less subscribers, more subscribers. It just simply autonomously publishes. Like you have a temperature, weather sensor somewhere in Colaba, Indian Meteorological Center. They will give you rights to go and look at that website to collect the data for your application or your just information. So the publisher, that IoT data device that they have put it somewhere in Colaba, will simply publish it in a broker, a server, and forget. So there may be subscribers of 100,000 people in a day subscribing the data. It's not done. So that kind of it's been de-linked from the producer subscriber model, de-linked to the hard connections, not hardware, even otherwise, even if it is a wireless, there is no connection between a producer and a consumer in this. So that is the way this has been modeled. Like traditional cloud server also can achieve this, but it cannot be as simple like this. So this is what it is. Multiple subscriber message from one publisher at the same time also. I'll just show some this thing that will be making it work. So this is what this simply publishes into a broker. I said broker. Broker is nothing but a server. Somehow MQTT even use this term called broker. Otherwise it's a server. And then so many people come and consume it. So it's completely asynchronous. When it is published, when it's consumed, it's completely asynchronous, and they don't know each other. Whereas it need not be always one way. Here it shows in a more simplified these publishers. Need not be. Sometimes it may be as small as the device as possible, but it can still be two-way. The same publisher can be also a consumer. That's also possible. See, that's why this is shown here. It also subscribes. It goes to the broker and gets some data to act on it. Suppose it's a temperature, it's an IoT which looks at the temperature of your house. okay, or cold storage thing, and it keeps publishing so that people they know all the cold storage, what temperature it is at any given time. But you want to take some action also. The same small IoT has got a relay which can switch on or switch off the air conditioning or the chiller. You can go and subscribe and see what is the action. Suppose they will change, this is winter, and so they are saying now switch on even when the temperature goes to, down. You now switch on only when the temperature goes down very low. So you take that, you go subscribe and see that, and then do the action itself. So it's possible. So IoT can be both a subscriber and producer as well. But by and large, this is a more common architecture. And the protocol, I won't go much in detail, but I'll just quickly run through. This is how the protocol works in a very high level. It says connect, then connect acknowledge from the source publisher, and then this is a broker. Everybody is going to the broker, both the subscriber and publisher. Then subscriber asks for a subscription, and then it gets an acknowledgement. Then it asks for which topic. In MQTT, it's called as topic. So, like suppose Manoharan house number 1 and bedroom 4. Then that is a topic. It's all defined in the topic. If you go in detail of that, you'll know that how come. It tells, then you'll go and get only that, not the whole lot of Manoharan's house, all bedroom or all the room's temperature. I might have IoT everywhere, temperature of 4 locations, but you can ask very specifically for that. That is what is called as topic. You ask for it and it gets back the data after acknowledging it. So this is what in a very simple way it works between a subscriber and a producer. So yeah. So this time just telling you in case people are more interested, you can go into all variables this side of This I just put it on to say that how like it is. See this variable header is not there always. It can be depending on application. This is there, of course. This is your actual payload, actual data, temperature, pressure, whatever. And this is the real control rate. Okay. And the whole thing is in 4 or 5 bytes only compared to 154 bytes. And what the first one does is your packet type, flags, small description on this. 1 byte itself is broken into this 4 bit. So compact it is. That's what I'm trying to show by this. There's not too much of space. This won't be there in any case. And this is message. That's all. And then you have payload. Very light. That's what it has to be because it has to conserve the bandwidth available itself is less, and then it has to conserve the battery life. Yeah. The most important is now as the expectations always grow when the technology grows. When you do a upgrade, suppose there is a dishwasher in your house and it's got IoT. They keep changing now the software and all very often. Not often, at least they know there was some accident somewhere, they want to revise the firmware. You can do in IoT. They can send it as long as your device is connected and remains connected. Fine. You get the latest like in your phone. Your update goes on when you're in the night, sleeping anytime, or anytime your upgrade goes on to all your apps. Similar thing can happen in IoT also because it supports photon. That is firmware upgrade over the air, which is a necessity. Slowly it becomes necessary. Like I said about a washing machine. So similarly, many other things, even vibration sensors, some calibration, new algorithm has to be loaded in that. They found a bug. So they can do that. After selling millions of this, they discover there's some bug. How you can go and do everywhere? So you can't go and visit places. So this FOTA is also supported by this very NB-IoT. So it allows FOTA. It's quite reliable, the NB-IoT transmissions. Despite being secure, it also allows all this. This tells what are the command sets available in the MQTT protocols. Not very, but this is just for thing I put this. So it is publish, acknowledge, then top. So many others, some more I put only one slide out of it. So it's quite, though it's so small and tiny, supports all this, so many actions, so many data exchange methods of data exchange is supported by NB-IoT with MQTT.
You have limited time now.
Oh, sorry. Okay, I have almost finished. So I will send the design to, they have come to the vibration part. Expert on this. So this is how it looks. Many of you must have seen. This is good. There is something of Amazon written here. What it means is it's connected to Amazon cloud. Amazon gives a free cloud for secondary. for certain numbers, otherwise you have to pay. You can put it in your cloud. If you're a small company selling this, you can host your entire thing on Amazon Web Service, AWS. That's what this is connected to AWS, that is what is shown here. I'll come to this. This is how the full architecture is. There is a sensor here, okay, and then in a place there will be a gateway. Normally this won't go directly to your tower or get connected to the. It will go to the gateway, wherein some more NB-IoT is in that place. Will all go to this. Will all be hosted by this gateway, and from the gateway it goes to several things like cloud here. Then it goes to directly an app also. If you have an IP and all, you can directly. You can configure it to directly send to this and to the servers here. So this is how normal standard architecture. So when you do it in the plant, Industry 4.0, this will be followed. It will be more secure and all, right? You go always to an IoT. Most of these do, though they can go directly to the cloud. So normally it won't be done like that, other than in the consumer applications and all that, you know. It will be normally like this. Then in the sorry, this one. Yeah. Just show you. Useful to.
So we have limited.
Yeah, I finished. I'm just saying this. I'm going to show this, and I'm going to be off. Yeah. So even this kind of signals, which you all know, this is how it is. A typical vibration sensor will give signals like this or even more. Even this can be done on IoT. So you can tell it to program the device to transmit every 1 hour, that's 20 short time. Or if you want, you can make it to transmit every 10 minutes also, depending on your application. But it's possible. IoT is not a very small datagram or telegram kind of a data only to set from a sensor in your bedroom to take the box, etc. You can do even this kind of thing. That's why it's becoming more popular. Such complex things you can set. Or you can even process it in the IoT there itself in the head. Depend on the application. And then you do everything, only send the alert to the server. But you don't have the processing power, you want to, it can come to very low cost thing. Even a 10 HP motor, you can do this nowadays. But you do all the processing as well by sending this once in every 15 minutes, or 10 minutes. So accordingly, the battery life will change, which is obvious. So it says, just for example, sorry, I'm not able to search that, but you can, I leave it and then you can probably go through it. It says to do it for once an hour, this thing, and then it sends and stops, and again it sends. You can get about once in an hour, or once in 4 hours, then once in an hour, or a few minutes. Once in 4 hours can give you 8 years battery life. The embedded battery can come to 8 years, very long time. With this kind of signal going, one shot, and then wait for 4 hours. You want every 1 hour serious, then you can, but then battery life only change. For 2 years battery life, if you want, every 2 minutes you can keep sending this kind of signal. So that is the kind of level that it has. So thank you very much.
Joseph, Jerome Duffy from Intelligent Production Technology Research and Development Center 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 from Intelligent Production Technology Research and
First of all, I would like to say thank you for Dr. Niraj Deshmukh and Dr. Dhananjay Deshmukh. If there is no their help, I cannot present the paper. And can you give me just share the link? Can you give me just share the link?
So you can share your presentation. The option is to share the request. So you can share your presentation. The option is to share the request. You can share your presentation. The option is to share the request. Yeah, sharing option is enabled. Sir, sharing option is enabled. From your side, you can share. Sir, sharing option is enabled. From your side, you can share. Sir, sharing option is enabled. From your side, you can share. Hello, sir. Am I audible to you? Hello,
You
sir, am I
cannot
audible to you?
show my slide. You cannot show my slide.
Yes, Dr. Sasaki, you can
Yes.
share, screen is here. You can start your slides from your end, no issue.
There is option
Please,
to share.
there is option to share. Please share your file.
There is option to share.
There is option to share. Please share
Yes.
your file.
Please give me the right of sharing. I cannot share. I put switch on the link shares, but it's not active.
You can now share. So
Yes.
you can now share.
Yes.
You can now share.
So you can see the slide.
Yes, yes, sir. Your slides are visible, sir. You can.
Okay.
Yes, yes,
Today's
sir.
my
Your
talk.
slides are visible. You can.
3D vibration control of fixed manipulator using universe system and spring feedback. So, and my research background in industrial load has, due to the weight reductions, it's make energy saving and speeding up. This due to the low rigidity occurs of elastic vibration and deterioration of accuracy. So, which we demand for improved vibration control performance in friction manipulators. So this is the program of friction manipulators is a time delay system and transfer function has unstable zeros. Real part is real positive and occurrence of undershoot like this. And need to design methods. So in the proposed method is further translation. So accuracy in the proposed method is and also further translation. So accuracy in the proposed method is also further translation. So accuracy in the proposed method is also further translation. And also the derivation of equation of models. So also the derivation of equation we can derive and models. And so also the derivation of equation we can derive and models. And so also the derivation of equation we can derive and models. Zero cancellations and eliminate the effect of false. So this is a control cancellations and eliminate the effect of using the so this is a control cancellations and eliminate the effect of using the so this is a control cancellation. Also, this is an experimental result. Is you can see the joint one. Also, and this is an experimental result. Joint is we can improve of 3D vibration control and control performance and vibration suppression performance of flexible manipulators. We can improve number one 3D vibration control and control performance and vibration suppression performance with conventional flexible manipulators. So we can improve number one 3D vibration control and control performance and vibration. If possible.
Chairperson is not able to. Question and answer session later. So we'll contact him.
So we'll contact you directly and if any questions.
Yes.
Okay. So I am audible.
Possible.
So you just tell your question to him.
Why do you choose?
Why has he chosen aluminum material?
Use the chairperson.
So we'll contact you directly. Why have you chosen aluminum in place of other materials?
Yes.
Okay.
Why have you chosen
audible.
aluminium in place of
So you
other
just tell your
material?
question to him.
Yes. And so,
Why do you choose?
at first we use two of aluminum, but it's too flexible and
So we'll contact you
it's
directly. Why have you chosen aluminum in place of other materials?
remains a residual strength and a bit change
Why
to
have you
the
chosen
and
aluminium
also
in place of
I,
other material?
I set and so
Why do you choose?
at first we use two